Bismillah ar-Rahman ar-Rahim. For my students in section 7, we have noticed during the experiment that the pressure gauge at the discharge of the pump was declared to be faulty. It wasn't reading correctly, but I believe that something happened in here, probably a miracle, and now the gauge looks to be fine. And as you can see now, guys, the pressure gauge shows a value of 6 bars. لاحظوا اللي هو red scale. We have a reading of 6 bars at 10%. At 10%, I'm going to switch even to the auto mode. Then let me switch now to the auto mode. You can see now the gauge is showing a value of 6 bars. لاحظوا انه the valve is 47% open. جميل. That's why at this portion of the pipeline, and this pipeline is closed, this valve, bypass valve, is closed. Now the more you close the valve, the more the pressure, the more discharge pressure of the pump we will see. Okay? But the more we open the valve, كل ما فتحنا الفالف أكثر, the more water flows through the discharge, and that causes the discharge pressure to decrease. يبدأ ينزل معك discharge pressure. But now at 10% it reads around 6 bars, and alhamdulillah. Let's go to 20% set point. Okay. And I'm doing this to show you the relationship between the process value or the flow rate and the discharge pressure of the pump. And we will see that they are inversely proportional. العلاقة ما بينهم علاقة عكسية. Now the process value reads 20%, as you can see. And just give it a few seconds to stabilize. It's matching with the set point. And if you look at the discharge pressure right now, it's slightly decreased from 6 bars to 5.8. نزل من 6 إلى 5.8. كل ما فتحنا الفالف أكثر, the more you increase in here, guys, the more you increase the output signal, the more you open the valve. This is a fair closed valve, and the more you open the valve, the less discharge pressure you get. That is true for fixed speed pumps. تعالوا نشاهد البمب اللي سرعتها ثابتة. هذه البمب عندنا في التجربة هذه. In this experiment we are running the pump at fixed speed. So usually you have a fixed speed pump followed by a control valve to control the flow. كل ما زودت أو كل ما فتحت الفالف أكثر, كل ما بدأ ينزل عندك discharge pressure. ف 5.8 bars at 20% flow. Let's increase the flow rate now to 30%. You can see the output signal is increased. تقريبا now it's taking some time for the process to stabilize, but the higher the set point, and because the sensor is highly sensitive, this is a magnetic flow meter, and we have said previously that this is a very sensitive sensor. As you can see, the flow rate indication keeps changing all the time. That's why we are experiencing the fluctuations in here. تلاحظون مسألة الفluctuations. So let's go back again, 30. Now it reached 30%. Let's see how much is the discharge pressure of the pump. You can see right now it reads 6.6, and you can tell that the it's fluctuating a little bit. We've got some fluctuations, but it reads around 6.6 bars. So for 30%, it reads 6.6. Let's go to 40%. So the pointer was fluctuating. We are increasing now the flow. You'll see that will take much longer time compared to the lower set points for the controller to stabilize the process. But it keeps changing all the time. And look at the digital display of the sensor. We've got some high fluctuations in here. And the discharge pressure at 40% reads 5.4. Okay, look at it. The pointer is almost at 5.4. So what we can conclude is that with the fixed speed clutch control valve configuration, there is an inverse relationship between the discharge pressure of the pump and water flow rate, or the discharge flow rate of the pump. The higher the flow rate, the more you increase water flow rate through the system, the less discharge pressure obtained as we said before, a discharge of the pump.